Hello. Hello. Okay, so we are live. And after almost 2 weeks we are live. After almost 2 weeks we are live. After almost 2 weeks. So last time we I think solved this till this problem game roots. Okay, so 5th Jan. No, we did not solve this one. We solved till longest flight route. Okay, so today I think we will solve game routes and these two planets questions if there is time, and otherwise we will solve game routes and planet queries 1. Okay, so let me open the board. Okay, okay. Graphs. Longest flight. Okay, now we will solve the next problem, that is game routes. Okay, so game has n levels connected by m teleporters. So basically n nodes, m edges, and our task is to get from level 1 to n. The game has been designed so there are no direct cycles in the underlying graph. In how many ways can you complete the game? So number of ways you can complete the game is basically in how many ways you can reach the nth node from 1, starting from 1. So it is a simple BFS, I think. So for example, let's say our first node is here, second node is here. I think it is a directed graph. This is a directed graph. See, they mentioned directed cycles, otherwise they would not have mentioned it if it was not a directed graph. So it is a directed graph, and let's say this is how the levels are designed. Okay, this is how the levels are designed. Let's say there is no cycle here, so to reach 6, basically number of ways we can reach 6 will depend on number of ways we can reach its predecessors, basically 5. And how many so if it has multiple incoming edges, okay, so we will need to multiply all of that, since it is a like If there if from one path we can reach, let's take this for example, 2 for example. Reaching 2 we only have one way, basically coming from 1. Reaching 3 only has one way, coming from 1. Okay. 4 we can reach from 2 only, so it is also 1. 3 we can reach from 5 only, 5 we can reach from 3 only, so it is also 1. But no, here 5 can be reached from 3 and 4. Okay, 3 or 4 basically, not and, 3 or 4. So should we multiply it or add it? So basically reaching 5 we have two ways now. We can reach from 3 or we can reach from 4, so we will add it, so it will be 1 plus 1 2, and for 6 it will be 2. So the answer is 2 here. For example, here in the test case also, for this test case, we have connections from 1 to 2, 2 to 4, 1 to 3, 3 to 4, and also 1 to 4. So reaching 2 we have one way only, reaching 3 we have one way, reaching 4 we have 1, 2 and 3 ways. What is the answer? Answer is 3. So we need to add one. Okay, so implementation is simple. We will have first of all the graph input. I need to make a some type of template for graph inputs. I keep forgetting it. Okay, anyway, so let's take it here, and the graph, we will store it in adjacency matrix. Okay, so it will be n plus 1, and we'll take the input, let's say, and we will push it. It is a directed edge, so input is done. Now we will do BFS. Okay, for that should we, okay, we will have a DP, modulo this, so we will have a DP. This DP will be of n plus 1 size, initially all 0. I will set DP1 to 1. Okay, now we will have a queue. This queue will be like for processing in BFS. I will push it. Okay, and while not queue is empty, I will pop it out. Okay, and what we will do, push DP. We could have done pull DP, but for that we need reversed graph. Okay, so instead of doing that, or we can store reverse graph only and then do that. We should do push DP now. Let's see. Both will work. So We are doing push TP here, so we will traverse all the nodes, adjacent nodes. Okay, and we'll do simply, there is no cycles, right? So we don't need to check for any visited or not visited thing also. So we'll need to do simply this: dp node is equal to 1 plus dp p. Not 1 plus, or 1 plus. Okay, 1 plus. This, and we will do mod what is the mod value. Okay, done. And okay, we need to push it also. We will push it in the queue, so node will be pushed. Finally we will return this. Let's see, answer is 3, and I think this should work. Okay, submit it. Let's try to submit it. Okay, TLE, why TLE? Okay, let's try to draw one of these. We have 4 to 7, 4 to 2, 8 to 5, 6 to 10, 3 to 2. Why am I drawing graph visualizer? Okay, we have the graph. Okay, so the last one is 10. No, delete this. So we start from 1, then we go to 4, 6, 3, then from there we will go to 7, 10, 2, 10, 2, and again 9 also, and 5, and then 8. This is a directed graph, no, so directed. Okay. Okay, so we start from 1. It will be 1 here, 1, 1, and 1 here. Okay, so for 2 it will be 2, then for 10 it will be 1, 2, for then 3 from 3 also, so 3. For 7 it will be 1, but for 10 it will change to 4. Okay, let me see it. Okay, we are adding something we should not be adding here. I think we need to keep track of what is being added to the queue. Which one true? Uh, let's not do it this way. Let me try doing it this way. And 10 is equal to and say set or int out degree is equal to your adj n or p dot size, and for those q dot size. Okay, I'm doing reverse edge, and in the reverse edge wait, I need the topological sort for this, right? Why am I doing it like this? There's a proper order for it. Do we need order also? We know that if we start from 1, if we can reach n, mm, think the problem solution is very simple, but I'm more complicating it.
What could be the solution then? Okay.
Number of ways to reach 10 is 10 in this case. Okay. 6, 7, 3 and 9. 6, 7, 4, 3 and 9. To reach 9. How many ways we can reach 9? To reach 9 we have 1, 2, 3, 4. 4 ways of reaching 9. So for 10 it will be 4 and 4, 8. Okay. I need a top sort. So let's make a top sort. TS and what we need is we need in order listed in degree. So we'll have ind n plus 1 0. Okay, and here we will do ind b plus plus. We need a q, and this will just be a q. Okay, we'll use this q only. So we'll have a q here, and then we'll do this for I is equal to 1 to n plus 1. If ind I is double equal to 0, then we'll do q dot push I, and then while not q dot nt, while not q dot mt, we will push it back to the top sort. Okay, top sort is done. Now that we have the top sort, is there any scenario where so there is no cycle, so that means there will always be a top sort. We need dp here, dp1 is 0, we'll push 1, we'll first clear the queue, and then we don't need this now anymore. Okay, this is done. Now for auto I in ts, Any counting problem with indirected graph will require what? Topological sort. That is one thing that I learned today. See, now we are playing a game of consisting of n planets, and let me write here first. Wait. Top sort, then counting BFS. Okay, we are done this problem also. We are here at planet queries 1. N planets, teleporter. Okay, we are starting on a random planet and traveling k teleporters. So, and the question is which planet we will reach. Which planet we will reach after teleporting k times. Okay. It is possible that di is equal to I. So there are self loops. K can be up to 10 to the power 9. We can teleport back also now, so it will be a undirected graph. Undirected graph. Mm, we need cycles. Mm, and if any of the node is trapped or is in a cycle, then if any node is in a cycle, then for need to find after k jumps where it will be, where will we be in that cycle also. So nq, but cycle finding will not work for the given n. I could run a DFS that will not account for every cycle. I'm definitely not going to tell us who is involved in the cycle. So there is a different approach to this. How was I able to solve this back in 25? I don't know. I don't remember. Solution must be easy one. Let's look at the solution. Holy shit. It's a DSU. How is it working? Okay, this is Kosaraju's algo. I can see, but am I even using that? So binary lifting. Okay, so this is not something that I have cooked up. I must have followed some tutorial or something. This is not something I could write. Nah. Okay, but the solution is actually very smart. So what they're doing is basically they're doing binary lifting type of thing, where they will start with one jump and gradually increase the jump size with two when in in binary shifts, basically to uh, so that the carrying part of the problem is easy. Okay, so let me try to explain this. We are given this input, right? This one. So here what we are doing is, we know that this is the first jump from each node to other, okay, whatever. So we will have something like this. This is k in this direction, this is the node in this direction. So 1 2 3 and 4 after first jump. Okay, this 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 we will have 2d dp. So after first jump, where will one land? One will land at 2. Okay, 2 will land at 1, 3 will land at 1, and 4 will land at 4 only. After the second jump, what will happen? After second jump, what will happen? So from 2, 1 can this will go to 1 only, and 1 will go to 2, again 1 will go to 2, and 4 will keep at 4 only. Then from 1 it will be 2, 2 to 1, 1, 4, 1, 2, 2, 4, 2, 1, 1, 4, and again 1, 2, 2, 4. So we have all the jumps here. So suppose now we have this query 1 and 2. So here it is x and this is k, right? So we start from 1. We see that we are given k is equal to 2. So what we can do is we can directly return xk from this jump table. Okay, so 1 after 2 jump will be at 1 only, so we will have 1 only. Okay, this is jt, nothing but jt. If we have 3 4, if we have 3 and 4, so jt for 3 and 4 will be 3 and 4, it will be 1, so it will be 1. Okay, no. This is the first jump, na? So okay, I messed up. I actually messed up. Sorry. So this is the 2 to the power 0th jump. This is 2 to the power 1th jump. 2 to the power 2th. 2 to the power 3th. Okay, one thing is we are not filling it correctly. So after the second jump, what will happen? This is the second jump. Okay, so this is the fourth jump then. So what will happen in fourth jump? One will go to two and then again go to one. Okay, so it should be one here, right? So how do we do the transition here? Basically, to do dpxk, what we need to know is what is the answer for dpx and whatever k minus 1 is. So it is like this. To calculate where 1 will be after 2 jumps, we know it will be at 1 only. Okay, so whatever wherever we are right now after 2 jumps, where we will go after 4 jumps, so it will basically be 2 to the power 2 into 2 to the power 2. Okay, so we know this part, we will calculate this part. So we are not directly jumping to 4 from 1, we are going like this, which is like breaking it into half. So 1 after 1 jump it will be at 2, 2 after 1 jump it will be at 1. So, okay, so to calculate where will 1 be after 2 jumps, we will check where 1 was after 1 jump, and for that from there we will jump 1 more. So basically we will check where 2 will go after 1 jump, so 1, so we put this here. Okay, so you see we need to have the knowledge of where we are right now and where we can go after half jump basically. So this is the kind of transition we are looking for. Not k, let's forget about k because it will be confusing, then we'll use t. Okay, so the thing is after two jumps 1 will be at 1 only, so 1 1. Okay, after 2 jumps where will be 2, where will 2 be? Okay, so it is at 1 right now, and 1 will go to 2 after 1 jump, so here 3 after 1 jump is at 1 and 1 can go to 2, so it will be 2. 4 is always at 4, so 4 is always at 4. To the power 4, 2 to the power 2 to the power 5. 4 4. Okay, now here after 4 jumps, so we need to jump 2 steps from here, so it will be 1 only. Similarly we need to jump so all of this will be 1 only because we keep repeating the same thing because it is a even cycle now, so we will be at the same place after even steps. For 2 after this we will go to the same place because this is also an even cycle. For 3 it is 3 is also now trapped in an even cycle. So this is also stuck in 2 only. So ultimately the answer we'll get is 1 to 4. Okay, let's implement this. We don't need this, need only this. Wait a second. Okay, now let's copy this, copy the input. Okay, so let's make a table key. The table will be jump table. Size is basically n plus 1. And in here we will have k, whatever k the maximum value, maximum bits k can have. So since it is 1 in 9, so I'm taking 31. Okay, all initialized to 0. Now we'll take input. This is done, and now we will jump 0th jump will be, this is not 0, it is basically 2 to the power of 0. So first jump, we are looking at first jump only. It will be AI only, and after this we will do JTI and we will have limit to 31. Now we will have another going from J to limit. We will do JT should be like this. So we are going from I j is equal to jt jt I j minus 1. Okay. This should be also we need to normalize it. We'll do minus minus ai. This is done. After this we need to solve query, so we will take input x and k, and now we just need to bit shift it. Okay, so basically for I in 0 to limit, if k and 1 I is true, basically if there is ith bit set in k, then the answer will be whatever our jump table gives. So how am I jumping? I don't understand this. Okay, we will jump I, and after this we'll output answer just like that. Zero, 1, 3. Oh, so we need to normalize it again. This should I mean the code is same, so this will work. Wrong answer? Why wrong answer? there anything I'm not doing right? What is it? Really? Okay. Was not expected. Mm, why really? Hmm. Might be because I'm using int. Who knows? See, it was because I was using int. This is a little different, and I think we should leave it for tomorrow. Uh, uh, we solved 2 questions today, and yes, we'll end the stream here. So, thank you for joining, and I hope you have a good time after this. Have a great dinner and a peaceful night. Okay, bye then. Peace out.